Okay, so open up Grasshopper and open up Rhino. So I guess you have to open up Rhino first. um, let me save this. And you do that by going into the command line here and typing Grasshopper. And it will load up. It'll take a minute for it to load. I generally work with half and half the screen and half the screen. Is that cutting off that edge? There we go. Okay, does everyone have Grasshopper open now? Okay, so the first thing that we're going to do, I'm just going to move over here into a blank screen, is we're going to create a point. So let's just go over here and type point, or click and drag, and let's just put a point down onto the canvas. Okay. And then what we need to do is I'm going to show you just a little bit about Grasshopper and its overview. Hopefully you guys have watched some of the video tutorials that were on the website, looked at some of these things so you're a little bit familiar with it. But basically what Grasshopper is a graphical programming language. So it allows us to think about the commands that we're doing, and basically what it does is replicates the commands. So we think about it in a linear process, kind of like how do we create a rectangle, right? We click a point and we start another point, and by 2 points we can define a rectangle. Well, that's the same kind of thing that we're going to do here. So in basically some overview, I'm just going to quickly go over this. Up along the top we have the typical file and display, those kind of solutions, those things that we don't really need to worry about right now. But mainly what we want to focus on are these tabs. So these parameters, math tabs, these are all of the functions that we can find. And if you'll notice, there's more if you click down at this bottom piece here. And they're grouped into the type kind of categories. So surfaces has all of these different things. So analysis means how can we get information from a surface. Freeform is the creation of freeform surfaces. Primitives would be creation of boxes and spheres and things like that. And then utilities, which would be like tools that we can use on surfaces. And that goes for the same with curves. It has a similar sort of thing. Vectors. So an important piece here when we get into this a little bit, points and vectors are almost the same thing. The difference between a point and a vector is that basically a vector adds a directional piece of information. It starts at a point and then there's a directional piece of information. You guys can remember that from geometry in class. So when you're looking for a point, it's under the vector, and so here are the point creation tools here that we can look at. And we have vectors, and those things come into play because we have to be able to tell, we use vectors to tell what to do in 3D space. So if we want to extrude something, we need to tell it which direction do we want to extrude it to. So in the Z direction or in the Y or the X. And so vectors allow us to do that. So if you click over here on this vector tab, you can see that we have a unit X vector, unit Y. And so basically that's basically saying go 1 unit, whatever that unit is, 1 unit in the X direction or the Y or the Z. And then there's some ways to create more complicated vectors if you want, or if you have a vector. So sometimes we're referencing a lot of times geometry, like we're going to do, like referencing this point. We can get information from that. So that's basically an overview. And to show you how to use this, you basically you just click on what you want and drag it down here, and then click again, and it will create this geometry. Okay? So that's an instance. This is called a component. This background is called the canvas. And then these are the connection lines. This is how we pass data from one component to the other component. Normally in Rhino, what we would do is select something and then run a command on it. That's very similar. We're just basically saying, okay, use this geometry or piece, and then use it to construct this next piece. So very simple. So we've created a point here, and we can also get some information from this point. So let's say that we want to deconstruct the point. I can just click here and drag and connect, and so now we have the point. Now, some other things about these components that are handy is if you just hover over it, it will tell you what it does. Constructs a point from X, Y, and Z coordinates. If you hover over this, it'll tell you what it's looking for. Give me an X coordinate. Give me a Y. Give me a Z. So I could put in numbers here, and we could do that by a couple of different ways, and I'll show you that in a minute. But we can also hover over and deconstruct, and you can see that down there in this spot here, 0, 0, that is telling you the information that's contained. So if I come over here, for instance, you can see that that list shows me a list of all kinds of things that are in that that box there. Okay. So what we're going to do is just quickly construct this, and then what I'm going to give you is I'm going to upload this. This is a picture of that whole definition. Okay, so what we've done today, we'll have this picture, and so you'll have the video, and then you'll have this piece, and all I want you to do is use this to construct and practice putting this together, and then that will give you all of the information that you need to basically take this and use it to create your columns for your project. Okay? And this is really only for the outside columns and the columns that are kind of in that space. Yeah, Austin? Or Jay, sorry.
Just let them know that in Grasshopper, when you first open it up, it shows the word of whatever that script is, and go on display and make sure that show icons.
Oh,
Icons.
yeah. Okay, so go display and then draw icons. I think it defaults to that, but I find that really, to me, when I don't like it. So I draw the icons. I'm a visual person, not a wordy person. So, okay. Thanks for pointing that out. Okay, where were we? All right, so wherever in your project that we're going to have tilty columns, this is what we will use to do tilty columns. Okay? But for now, we're going to use this as a test bed. So this is something that I highly recommend as a function. You want to build, whenever you're using Grasshopper, you want to build small and test it and make sure you got the kind of basic piece of it. Because what's great is that I can basically load any type of geometry and this thing will replicate itself. So let's say this point right here. So let's select that point that we created. And we want to tell it to use that point in Grasshopper. So the way that we do that are we can do it in a couple of different ways. So we can go over here to the Parameters tab, which is over here on the top. And then you see here that we have different types of reference geometry. So we can reference in a point, or a vector, or curves, or a basic geometry. So that's how we do it. So we want to do a point. So we click on that, and we bring down a point. And you can see here I've already referenced a point. But now that I have this selected here, I can right-click on this and choose Set One Point. And that'll reference the geometry. And you can see that, so now that has a kind of a red X. And if I select it, see how it turns green? So that tells me that that's the reference geometry. So to show you, this was the other point that I referenced. If I just click and drag and connect this, it starts to select and put these pieces together. So it references these different types of geometry. Okay? So we're going to reconstruct this. All right, so we have our reference point. And then we need to get some points in here. So there's a couple of different ways that we could do this. So I use this reference point, but if I had a bunch of points, I could use that as my points as well. So you have already created all the points for where the columns are located. So you would select all of those and then right-click on this point container and then say Set Multiple Items when you're ready to build that. Okay? So what I'm going to do here is I want to have some points to work with, and there's a couple of different ways I can do that. But what I'm going to do is just create a grid of points. So let's go to Vector and click on this square here and drag it down. And then I'm going to connect this here. And you can see that I create this grid. Okay? And if you'll notice, we have the cells, which are these points, or these blocks that we can see, these red. And we also have points. So one way I can show those points, and I'm going to show you another way we can add. So if we double-click on the canvas, we can start to type point. And just like in Rhino, it gives us a list of commands. So I'm going to select points again. And I'm just basically grabbing that so you can see that there's points on each of those indices. Okay? Now you'll notice that these wires are two different styles of wire. Okay? One is a single kind of line, and then you have this kind of fatter dash line. So inside Grasshopper, it looks at information in two different ways. So it can look at it in a simple list. So I just have a list of points, okay? Or it can list it in terms of, can you kind of consider it like folders? So I can group information together. I can group a list of points. So I could have, let's say, this line of points. I could put them and group them together into what the language that Grasshopper uses is a branch. So if you think about it as a tree, we start from the bottom and a branch contains things. I like to think about it as a folder personally. I think that makes more sense. Once we get that, that's when it's grouped, that information looks like this. So you can see down here, this list. I'm going to type panel. And you can see, here's my folder. and then these are the points underneath it. So this in Grasshopper language would be called a branch, and then here are the list of points underneath it. So it's kind of grouped lists. That can be really handy when we get into complicated things, but for this example we don't need it to be that complicated. So all we want to do is flatten this branch. So we can do it a couple of different ways. So what we want to do is just say, get it out all of the folders and just put them in a list. I don't care about having them grouped. So there's two ways to do that. We can right click and type and click flatten. Now if we look at it, you can see it's just a regular list. I'm going to unclick that. There's also another way. If I just type flatten, and I can say flatten tree. Now when we look at it, here's our list again. Okay, it's just a flat list. So there's a couple of different ways you can do it. Another neat thing about this is you have to think about it's copying, every time you move to another component, it's copying the geometry. So sometimes you're going to have overlaps of geometry and it's hard to kind of see them. So if you select something and hit the space bar, you can hide that geometry. So you can see how that goes away. Or if I click this, enable. You can also get that by right-clicking, and you can select preview or not to preview it. So a couple of different ways. All right, so we have that tree. And we flattened it. This is just there for demonstration purposes. You don't need it. So the next thing we need to do is we want to create kind of a random set. We want to move these points around to be random. So the way we're going to do that is by creating a couple of things. But the first thing we need to know is how many points are in that list. So I'm going to type length. And you see list length here. Click that. And if I connect that to that, now it will tell me that there's 36 items in that list. And I need that for this next step. Okay, and if we look up for here, what's our next thing that we're going to do is we're going to define the amount of movement we want around this point. So we're going to do that by saying move around between a negative this number and this number. Here's a range of numbers to move. Okay? And we do that by double-clicking. Now, you'll have to look, depending on your units, this will change for you. So I'm going to type, if I double-click a shortcut, I can just start typing like 0.3 and hit enter, and it'll automatically create a slider. And now I can randomly move these points in between here. Okay? And I need 2 of these. So I'm just going to commit Control C and Control V to copy. And then we want, as we can see up here, we want a negative number and a positive number. So that's our range, a negative and a positive. We want to move it back and forth. Yeah? Just double click on the canvas. So double click anywhere on that's open. Okay? Yeah. So that's what we're doing here is we're going to create this domain. And the way that we create that minimum is we can double click on that and we can say here's our minimum and maximum. So minimum would be -1 and 0. And you can click and drag or you can double click and edit in there. Click OK. So now I have those at -0.3 and 0.3. So then we need to construct this domain, right? So what we're going to do is double click on the canvas and type construct. Or type domain and use construct domain. That also can be found up here in math in domain. Construct domain is the first item listed here. So there's a couple of different ways. And then we just connect those two by clicking and dragging. Click on the end, point the little nub, and drag it into the second little nub. Okay, so now when we look at this, we have this domain that's from -3 to 3. And then what we want to do is create some random numbers. So that's what this piece, oops, a little fast there. That's what these things do. So we're going to create random numbers for the x direction and random numbers for the y direction. Okay? And so all we do is come down here, double click, and type random. You can see random is here. And we're going to need 2 of them, so I'm going to again Control C, Control V to copy and paste a new one. So let's look at what it's asking for. It's asking for the range of things. And then it's also asking for how many random values do we want. And then here is a seed. Okay, so when we do randomness in a computer, it's quasi-random. It's not like random, chaotic random. So basically what it is, it's an algorithm that based on a number, a seed number, it's going to create a random set of values. Okay. However, if I put both of these with the same seed number, I'm going to get the same exact values. So that's why it's quasi-random. So whenever we want 2 really random things, you have to change the seed number. So, and that's common with just about anything in computers and randomness in programming. So just to be aware of that. So let's connect our ranges. So here's our range, and we create that. So, and you can see, notice the icon up there, that's the little domain symbol. And we've got the domain, so we click there, and we click there. So those 2 are connected. And then the number of items that we have comes down from what we counted. So these, we want the same number as there are points. So that's why we counted how many. So we're going to connect those to the number. Yeah. Oh, unconnect it. There's a real easy way. So you can right click and click disconnect, or you can hold the control key down and drag it backwards, and that'll disconnect it as well. Okay, so the next thing we need to do is change these seed numbers so that we get 2 random different seeds. Okay, so what we're going to do here is there's a couple of different ways. I could say let's put double click and just type 5, and I could have a slider that's a 5 and do it that way. The other way I could do it is right click, and I can set an integer. So I could set it as 5 there. So now we have a seed at 2 and a seed at 5. And we can see these random values that are coming out. Okay. So what we want to do here with these random values, we have these random values, but we want to know that's the whole building. Yeah, that's the whole building. So we're only using a portion of that. When you really get into this, it's really fun because you can just create everything, and all of it's off of one little point. So it's really can be fun. All right, so now we need to say, okay, we need to create a vector because we want to tell it where we want to move, right? Which direction do we want this thing to move? So remember that we can go up to here to vector, and under this vector tab, we want to construct a vector, create a vector from x, y, and z components. So that's what we want to do. Click that and drag that down. So we'll connect one of these to x and one of these to y. Okay? And so here's our vector. Okay? And then we can also look at this. This is the length of a vector. So most vectors come out as 1. That's a unit vector is 1. And what this is telling us what's the distance between the original point and the other point. Not that that's important right at the moment, but just so you know what that is. Yes?
The two in the middle, what those are.
These?
Yeah.
Okay, these are our random numbers. So what we're doing is creating random values for x and random values for y, because what we want to do is move those points. We want to jitter those things around. Okay? All right, so we've got that. Now the next thing we want to do is move those things. We want to move it. So we're going to use the move. So double click, type move, and there's the move. And so what this thing is asking for is geometry and a motion, which is a translation vector or vector. So we've got our vector, and then we have our geometry, which are these original points, right? So if we connect these points down here, and we want the flattened list of points, and one of the reasons why I generally, when I do flattening, I do it here, is because sometimes you forget. You know, it's much easier just to go back and click that thing. But we're going to click here. You can see that it's defaulting to moving it up to the x. So that's why they moved up here. But now we're going to connect them to these, to the vectors. And so now we can see they're all moved around this point to some degree. Now, if yours is too much, you might have to go back here and change these. So you can see how as I'm changing these, it's moving. And this is what we call a parametric model. So we can just basically translate information. Yeah?
What would be the two domains for those scales? Negative 3 is the maximum one?
For mine, I had 0.3 and negative 0.3. And that's just based on the scale that I was working at. So if you're using a different scale or depending on the size of the model that you guys are at, you want to change those numbers until you get it dialed in. Okay, so we have those. So what's our next thing that we need to do? Well, we need to start to understand how this thing is going to be related to the roof. So as we know, the outside, some of those columns sit outside of the roof edge. So if we're looking at it in the top, some of them are sitting outside, but they curve inwards to the roof. So right now, if we define a roof edge and we try to extrude it the way we're going to do it, it doesn't know how to connect to the roof. So the ones that are outside of the edge won't be able to connect. So what we want to do is figure out a way to move those points that are outside of the edge and say snap up to the edge of the roof. So let's go in and define the edge of the roof. So let's just create a rectangle, and we're going to build it inside. Okay. And once you have that built, we're going to reference it in. So I'm going to double click and type curve, because it's a curve. And I'm going to look for this hexagon curve symbol, because that's going to relate into the curve. And then since it's selected already, I'm just going to right click and set one curve. So now that curve is in there, and I can use it as a reference. Yes, sir? Oh, okay. Yes? Jay, can you help out there? Okay. Austin or Dylan? Raise your hand. Okay, so once we have that, this piece here, what we're going to do is then move this and say, okay, here's what we want to reference. So the first thing we want to know is, okay, which side of the curve are these points? Are they on the inside or on the outside? So we can do this analysis, and what we want to be looking for is this curve side. So we can double click and type curve, and you can see it comes up to curve side. And that's also in the curve tools under utilities. But just curve side is easy. And so it's asking, we can look over these things, it's looking for a base curve, the points to test, and then a plane to test. So a plane we will get into a little bit later, but so let's say here's our curve, we connect that. And then these are the points we're going to test, are the ones that we just moved. Okay? And then it's going to give us left or right of the curve. So sometimes we'll get geometry and we can't really see it. So oftentimes what I'll do is just type, so if I'm dealing with points, I'll just create a point container and turn that on. And what you'll see is that what we're getting out of here are true false. So we have to figure out a way now to tell it to take out the ones that are, that test. Okay? So what we're going to do is use a col pattern, because we have a pattern now of true and false. So we'll type col pattern. And that's over here in the sets, in the sequence. So we can basically say, out of this list, take out these things. Col, C-U-L-L. Yeah. So here's our list of points, asking for a list, and then what's the pattern. So here's the list of points, the ones that we just moved. And the pattern we can look at as left or right. And it's going to be left. A curved side. So now that we've selected these things and they're outside, it's really easy for us to, then what we want to do is move that or pull that point to the curve, those points that are outside. So what we're going to do is pull point, start typing pull, and here's our pull point. Again, looking at, it's asking for a points, and then it's asking for a curve. So what we're going to do is connect the curve, and then the points, these are the points that we want to use because they're the ones on the outside. So see how they're selected. Okay, and now you can see how they've been pulled to the curve. So what I'm going to do is hide some of these. So I'm just going to select and then hit the space bar and hide those. So now I just see those points, okay? So now we have, okay, we have 2 points. We have 2 different lists of points. And so now what we want to do is say, okay, of those original points that we had, that list of moved points, and we have these ones that are kind of moved out and we've then pushed them to the curve. Now we want to say, okay, get the rest of those points that we had and replace them in the list. And we want to replace them in the order as the original list because we want to be able to connect the 2 dots together to create the column. So what we're going to do is use a couple of things here. And one is an item index, and what that's going to do is say, go and get the index. So think about a list as having a number associated with it. So each item has a number, 0, 1, 2, 3, 4, 5. And that's its index. That's its place in order. And then what we're going to use is this replace items. So we're just going to say, okay, take those ones out and put these ones in. Okay. Let's see, let's type index. So here's item index, that's what we want. And then the other one that we want are the replace. So we'll just get both of those out. Replace items, get those out, get them ready. Okay. So the list that we want to get the index of is this one here, which is this list, right, of 18 values. Okay. And then what we want to do is go back to this move geometry, because that's our list of things. So we're trying to find out where these things exist. And so now here's that list of the places in which their order, okay, where they resided. Okay, and so if we look over here, this is where we want to say, okay, that's our index, and here's our index. So we connect that. So that's saying, okay, in these spots, replace these items, okay? And so what do we want to replace them with? Are these new points that we moved. And where was the originals? So we want to go back to our original points, which are way back here. And we just click and drag those. Okay? So now we have them back in the order. There's 36 of them. They're back in the place that they wanted to be. So now we need to create, what we're going to do here is create a surface that's just going to represent our roof. And then we're going to take those points and we're going to say, project them up onto the roof. Okay? So what I'm going to do is create that surface. We could do it in Grasshopper, but I'm going to create one here. So I'm going to select our roof edge, and I'm going to go to Surface, Planar Curve. So now I have that planar curve. Now I'm just going to select that surface and move it up to where I want. Just drag it somewhere. And then to make it curved, I'm just going to turn on the control points. And I'm going to select this curve and I'm just going to drag this up. So now we've got kind of a curved surface so we can see. All right, now we have to get this surface, hit escape so you get out of the control point editing mode and you can select it. Now we have to tell it to, let's put that surface into our definition. So we'll double click, type surface, and again looking for the hexagon, black hexagon, which is always kind of item containers. We want that there. We make sure that the surface is selected and we right click on it and say set one surface. Okay. Then what we want to do is project points. to the surface. So we'll type project. We're projecting the point. There it is. Okay, so it's asking for the points, asking for a direction in terms of the vector, and geometry. Okay, so the geometry is this surface, so we connect that. The direction, what would be the direction that we're going to be moving in? Z, that's right. So we can just double click and type Z, and you see the first thing that comes up is unit Z. Project. Project. Okay, so we're going to click on the unit Z. Hey, Dylan? Okay, so now what we need to do is say what are the points that we want to project. So these are the points down here that we just all reordered and put together. And now that's what we want to project. So now what I'm going to do here is I'm just going to select all of these, hit the space bar, and hide them, just so we get less confused. Okay? So now as we look at this surface, we can see that these green points are up there on the surface. Okay, so what's the next thing we want to do? Well, we want to make them into lines, okay, which will be the center points of our columns. So all we're going to do is type line. And don't get confused, because the first one that will come up is the container for lines. But what we really want to do is use this line that creates a line between 2 points. Okay? So the first line is going to be, the first point in the line is that original set of lines all the way back here, right? And we want to connect that to, so here's the thing, if you hit the edge of the canvas, it will start to swing over. So we connect that to A. And then the second points are these new points that we just projected up onto the surface. And so now you can see that we have these columns created. And those are the center lines of our columns. And they're all ski-wampus in a nice way, like we want. Okay, so then now what we want to do is we want to make the curves or the columns, give them some surfaces. So, as you notice in the original building, they're square. But I'm going to show you an easy way. So, if we had circular columns, we could just use this pipe command and pop these in here. So you could create some pipe columns really easily. But we want rectangular columns, so we're going to do something a little bit differently. Okay, we need to tell it the size of a column. So how big are these columns? And then we know that it's going to be a rectangle. So the first thing I'm going to do is I'm going to choose my rectangle option. So if I go and type rectangle, you can see it pops up. And there's several different ways that we can create a rectangle. I'm just going to use this one. And so if you look at it, the X and the Z, it's asking, you can tell by this little thing here that that's looking for a domain. That's our icon for a domain. So we're going to create a new domain. So double click, type domain, and use construct domain. Or you could do this. Sometimes, if you know you're going to use it again, you can copy and paste. So let's do that. So Command C. And then just drag that over. So we have all of the basic components that we need for the domain. And we want them to be a square column, so we want that to be in both the X and the Y. And then it's going to ask for a plane. Now, this will be maybe slightly confusing, but a plane can also be considered a point. So if you have a point, it's going to default to the XY plane. So what we're going to do is we want to get the start and the end condition. So we want the start and the end points of this line. So I'm going to do end point and connect that to the lines that we've created. So now we have the start and the ends. And then, so I want them to start at the bottom. So I'll collect that point. And you can see now that we have these points here. And now I can adjust these based on their size. This one, endpoint. Yep. Okay, so now we have our rectangle, the shape of our rectangle. Now what we want to do is extrude them. So there's a couple of different ways to do this, but I'm going to use extrude linear, which is this one here. Because what that allows me to do is use those center points of those columns, the lines that we created, as the axis for the extrusion. Okay? So here it's asking for the profile, which is the shape, which is the rectangle that we created. So we connect that. This is the rectangle. So this is the rectangle. Now it's asking for the orientation, and so what and also at the start. So we're going to use the orientation. We want the orientation to be this endpoint, and then it's going to ask for the axis. What do we want to extrude? So we want to extrude the center lines, which are these here. So we'll click and drag those, and now you can see that they've started to be extruded. But what we want to do is give it to this endpoint. And so now we have all of the columns extruded up to the surface, to the roof. So that's pretty much it. So that sequence, now you have the basic sequence. And what I would do is File, Save, go up here and Save Document as, and then rename it something that makes sense to you. Okay, so the important thing to think about is that these starting points that you have down here, use the column points that you've already created. That will be your starting point. So you don't need this portion here, okay? And then make sure that to make this all work, you want to flatten it to make this thing happen. So those are the two kind of main pieces. And so you can take this same function and you can just pop it into your definition and just change which points you're using to extrude, okay? So that is the gist of the project and how to build it. And then Austin is going to show you some other uses of Grasshopper to create perforations in the shield. You want to do that today?
It's 90% there right now.
Okay, so we'll do that Friday. Let's work on this, try to recreate it. Now start to import this and use your base points that you have and start to help that. And Dylan and Jay and Austin will help with that.